Hello. So we are doing a project on automatic railway gates. So our teammates are Roshan Ramesh, Devshekar Patnaik, and Nishnath Nakar. Next slide. So here is the presentation overview. First we'll start with introduction, then objective, then literature reviews, methodology, hardware and softwares used, a work completed with result, conclusion, and then references. So let's start with the introduction. Railway gates are used to close crossings between the railroads when the train is passing by. Usually, these are handled by humans, so there is a possibility of human error. So we have a plan to automate these railway gates in order to avoid such accidents. And then next slide, objective. So the objective of our project is to design an automatic railway gate using a 8051 processor. 8051. Wait. Yeah, I need to cut this part of it. The objective of our project is to design an automatic railway gate using 8051 processor. The railway gates are opened and closed manually by a gatekeeper on receiving information from nearby stations about the arrival of the train. To avoid the human intervention at level crossings completely, we need to automate the process of railway gate control. So here are some research papers and some websites which we have referred to get information about the topic. So first one, we have used Electronics Hub website. In this, we got the circuit design for the project. And the key point taken from here is the circuit design. So the second one was a research paper by by B. Subramanian, A.S. Selvakumar, M. Sachithana, and T. Sai Kumar, Anisha Radhakrishnan. Here we have taken some observations that GPS can be implemented. So the key points taken from for our project is automatic railway gates control using GPS. So methodology, we use two IR sensors placed before and after the gate. If train approaches the gate, the sensor will detect it and close it using the motor. As the train reaches the second sensor, the gate will be reopened. IR sensors and receivers are placed side by side, so obstacle is detected when receiver gets the signal. So here's the diagrammatic approach of the methodology. Here is the road and the railway crossing. When the train reaches the first IR sensor, it closes the gate, and after crossing the second IR sensor, the gate opens.
Okay, so now coming to the slide, we will show the hardwares we have used for our project. So first of all, we have the microcontroller section. Here we have AT89S52 MCU and 11.0592 megahertz quartz crystal, two 33 picofarad ceramic capacitors, one 10 microfarad electrolytic capacitor, and two 10K ohm resistors, and finally one AT89S52 programmer board. As for the sensor and load section, we will have two reflective type IR sensor. An IR sensor is used in this project to sense the arrival and departure of the train. And then we will have two 1K ohm resistor and L293D motor driver IC. It is a motor driver IC used in this project to control the gate motor. It is a dual H-bridge type motor driver and is available in the 16-pin dual inline package. And at last, we will have the motor. Next. So now coming to the softwares we have used in our project. First of all, we have the Keel MDK. It is the complete software development environment for a range of ARM Cortex M-based microcontroller devices. MDK includes the Microvision IDE and debugger, ARM C or C++ compiler, and essential middleware components. Then secondly, we have the ProGISP. It is a software used to load the hex file onto the target chip, and Keel Microvision is the software used to create hex file using C code or assembly language. An ISP programmer is required to fuse the hex file onto the target 40-pin IC, which is 89S51 or 89S52. And at last, we have Proteus, which is a simulation software which is used to test our code before uploading it to the microcontroller. So yeah, from here, Roshan, I should take over. Yeah, bro.
So here we have the circuit diagram explaining how we've connected the circuit. This is pretty much how we've connected the hardware, how we have implemented the hardware. Here we have connected the interrupt 1 and 2 of the motor driver to port P2.0 and P2.1, and P3.0 and 3.1 are connected to the sensors. And there's one motor connected to the output. This is the hardware implementation. Here you can see the two IR sensors and the L29 3D motors. It's connected exactly how it's shown in the circuit diagram in the previous slide. These are the IR sensors. This is the motor driver IC along connected with the motor. This is the AT89S52 programmer. This connects to the laptop and can load the hex file onto the microcontroller. This is the AT89S52 development board. It has all the pins already soldered on, and all the hardware mentioned separately. There's the circuit connected to the power source. Here we have the IR sensor responsible for closing the gate, and this one is responsible for opening the gate. The one responsible for closing the gate is connected to port 3.0, and the one responsible for opening the gate is connected to 3.1. The motor driver is connected to the interrupt of the motor driver is connected to port 2.0 and 2.1. Unfortunately, the motor does not work, but we can show that the input from the IR sensor is being read by the microcontroller. So when the obstacle is being detected by the IR sensor, you can see that the user LED of the microcontroller development board, it goes off for a while, and then if another obstacle is detected, it won't go off again because the gate is already closed. Now once the gate is opened by doing that, now if I do the same thing, it goes off again. That proves that the code works perfectly fine. And Nishnath will continue with the societal impact and conclusion.
So now coming to the societal impact and the conclusion of the project. So automatic railway gate system control is a simple but a very useful project which helps in automatically opening and closing of a railway gate upon detecting the arrival or departure of the train. It is implemented with a very simple hardware and easy control, and human intervention at level crossings can be removed with the help of this simple project, and many railway level crossing accidents can be prevented. Next. So this is the website we have referred for our project, and yeah, that's all.
Thank you.
Yeah, thank you.